Hello everyone, myself Milan Patil. Today we are going to start with chapter 14, Chemical Effect of Electric Current. This topic is taken from class 8th science. What will happen if we touch an electrical appliance with wet hand? Did you ever try this? If you have tried, then you must have got electric shock. By the way, it's quite dangerous to do that. So do not try this activity at home. But by accidentally, if you must have touched any electrical appliances with wet hand, definitely the person is going to get an electric shock. It is very dangerous to touch an electrical appliances with wet hand. But why it is dangerous? Do you know the reason? Yes, because these electrical appliances work on electricity, and when you touch with your wet hand, electricity or electric current is passed from that appliance to your body. Therefore, it is very dangerous to touch electrical appliances with wet hand. In today's class, we are going to learn about what is this electric current, what are its effects, especially chemical effect of electrical current. We are going to see the electrical conductivity in liquids. In lower classes we have learned about electrical conductivity in solid, but now we are going to learn in liquid, electrolyte, non-electrolyte and electroplate. So let's begin with the lesson. What is electricity? Before I begin with this question, what is electricity? Let us try to analyze or understand that electricity has got huge application in our day-to-day life. There are various or numerous gadgets or devices that we use in our day-to-day life that run on the principle of electricity, or rather they use electricity. For example, the light bulb that we grow. Now I'm doing a lesson or recording the lesson using a laptop. So to run my laptop, I need electricity. Refrigerator, fridge, TV, AC. These are the some of the electrical appliances which runs on the principle, or rather they uses electricity. Okay. So what is electricity? It is nothing but a form of energy that produces light, heat, magnetic and chemical changes. So in today's class, we are going to concentrate on this effect, that is chemical effect of electric current. As I already told you, it is used to run electrical appliances. Okay, for example, electricity is used for the lighting purpose such as bulb, lamp, okay, LEDs, tube lights. It is used for the heating purpose such as oven, geyser, okay, hot plates. So these are the various effects of electricity. Now let us try to understand what is electric current. Okay, electric current or electricity is nothing but flow of electron along a closed path called electric current. Okay, so how do we define electric current? Electric current nothing but flow of electron along a path, and that we term it as electric current. Now, how do these electrons flow and why do they flow? Here lies the answer to your question. Then answer we try to see by learning about the structure of atom. Okay, we know that the atom is the smallest indivisible particle of an matter. Now suppose this is an atom, that's the nucleus. Okay, so the atom structure consists of the centrally dense particle called nucleus. In this nucleus, protons and neutrons lies. Whereas outside the nucleus there are shells or orbit like this, and in which revolve another subatomic particle called electrons. What are proton? Positively charged particles. What are electron? Negatively charged particles. Whereas neutron are neutral particles. These are three subatomic particles. Now, since there are two types of charges which are already present in the atom. What are those two charges? One is positive charge, other one is negative charge. Okay, so atom, by default, atom is always stable in nature. That means the number of proton will be always equal to the number of electrons. Okay, so by default an atom is always stable. Okay, now if there are more electrons or less electron, then we say that atom have got some charge. Okay, if this number of electron changes, then we can say that atom is having charge. So when I can say atom have a positive charge, suppose if atom lose an electron, okay, that means a positive charge is there in atom. When an atom can lose electron? When it is having extra electron. If atom is having this extra electron, then it can lose this extra electron. When an atom can have a negative charge? When it gain an electron. Okay, when it gain an electron. So atom can have either positive charge or negative charge depending on this variation in this electron. For electricity, these electrons are very, very important. In electricity, we know that flow of electron along a closed path. So for this flow of electron to occur, therefore, so now you know from where you have these electrons. Okay, and how do these electrons flow? There must be some carriers. So electrons flow through certain materials, and we know that wire is that component of electric circuit which help in conducting these electrons. So what is electric current? It's nothing but flow of electron along a path, and this we term as electric current. Now let us try to understand this flow of electron. In this animation you can see, suppose this is a picture of a conducting wire. Okay, conducting wire. Okay, we know that conducting wire will conduct electricity. What's the meaning of this? Conduct electricity means they will allow electric current, or they will allow electrons to flow to it. Okay, they will allow electrons to flow to it. So in this animation you can see the electrons are moving. Okay, how the electrons are moving? From where to where? Okay, from the negative to positive terminal of an electric cell. So in a circuit, it will always move from negative to positive terminal. Whereas how does the electric current flow? It is always from the positive to the negative. By convention or by default, it is from the positive to the negative. So this flow of electron, is termed as electricity. So now that you have learned what is electricity, let us now understand the further concepts in detail. So as I have already told you, how do the electrons flow, or how do the electrons move from negative to positive terminal, and how do the electric current flow from positive to negative terminal. Okay, this is by convention or by olden theories. We say that electric current moves from positive to negative terminal. Okay, now that's an electric circuit. Okay, now what is this electric circuit? It is a closed path. Okay, what is electric circuit? It is a closed path. It is a closed path where electron, I will write like this, electrons will flow. Okay, so what is electric circuit? It is a closed path where electrons flow. So now this electric circuit consists of certain parts or components. So let us try to understand each component in detail. So that's a cell. Okay, these are wires. That's a bulb. And that's the switch. So the basic component of electric circuit are cell, wire, bulb, switch. Now look at the animation carefully. What happened? When the switch is at the on position, what happened? The electron flows to the circuit and therefore the bulb glows. So such a circuit will be called as closed circuit. Okay. Now when the switch is at the off position, what happens? There is a break in the circuit. Electrons cannot flow to the circuit and bulb do not glow. Okay, such a circuit is termed as open circuit. Okay. Now let us try to understand the components of electric circuit. As I already told you what is open circuit, what is closed circuit. Let us now try to learn each component. Okay, now that's a circuit diagram. The picture that you see here is a circuit diagram. Now how do I draw this circuit diagram? So and here you can see certain symbols are there. This symbol, okay, this symbol. So let us try to understand each of this symbol in detail. The straight lines that you can see in the circuit diagram represent the wire. Okay. Now the symbol that you can see over here is a symbol for bulb. Okay. So that's a symbol for bulb. Okay, that's bulb. Here, this symbol that you can see is for battery. Okay, and single cell we represent like this. Okay, single cell we represent like this. That's a cell. Combination of cell, we know that it is battery. So that's a symbol for battery. Okay. Now, that's a symbol for a switch. Okay. Switch. Now this switch is open, that is off position switch. That's a symbol for, okay, I will draw it again over here. Okay. 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 So here we have switch, on position switch. Okay. So these are the basic symbols, and in your higher classes you are going to learn about these symbols. Okay, A and meter, that's V for voltmeter, and many more other symbols in your higher classes. That symbol that you can see over here is another type of symbol for a plug key. Okay, plug key is nothing but act as a switch only. So if like this is there, that means it's a closed plug key. Closed plug key, which is nothing but a switch. And that symbol is a open plug key. Open plug key. Okay, or a switch. So these are the components of electric circuit. Okay, as I already told you, what is an electric circuit? The path through which electrons travel is termed as electric circuit. As I already told you, there can be two types of circuit, open circuit and closed circuit. What's an open circuit means? There is a break in the path of an electron. So if the switch is at the off position, then the electron do not flow to the circuit and the circuit is termed as open circuit. What is in closed circuit? When the switch is at the on position, the electrons can move through the circuit, and that's a closed circuit. In this animation, when you can see here, see, when the switch is at the on position, so electron get a path. So there is a break in the path over here. When the switch is at the off position, see what happens. The electron do not get a path. So there is a break in the circuit and the electron do not flow, and therefore the circuit is termed as open circuit and closed circuit. Okay. That's a electric circuit, and this is how we draw the diagram. So let us draw the diagram for this particular electric circuit. Okay. So I will represent this circuit with the help of this. That's a symbol for bulb. Okay. So that's how I will draw the electric circuit diagram. Okay, as I already told you, electricity is nothing but flow of electron around the circuit. Okay, and who gives this energy for the electrons to flow? So the battery gives the energy, or the act as a source for the electrons to flow in the electric circuit. And this part we have already seen. The flow of electron along a path is termed as electric current. Let us now understand the cause of electricity. As I already told you in the previous slide, what is the cause for the flow of this electron? So the atom, we have learned about the structure of atom, and we have seen the atom consists of centrally dense particle called nucleus, where lies protons and neutrons, and there are orbits around this nucleus in which electron revolves. So these electrons have got negative charge, whereas proton have got positive charge. So when electron flow from, when electron move, we say that it is electricity. So when this electron jump from one atom to the other atom, and that's how the electricity flow from one place to the another. So what is electricity? Nothing but flow of electrons. Okay, flow of electrons from one atom to the other atom. Okay. Now that's a electric circuit. Okay, now let us draw a circuit diagram for this electric circuit. So we have a bulb over here, okay, which represent like this. Then you have a switch which is at the off position, okay, and here you have the, okay, here you have the cell. So cell or a battery, bulb and switch. So that's how we draw the circuit diagram. Now there are some material which allow electric current to pass through them, and there are some material which do not allow electric current to pass through them. Okay, they are termed as conductors and insulators. Okay, what are conductors? Okay, let us try to understand. The substances can be put under three categories basically. Okay, the one which allow electric current to pass. What's the meaning of that? They allow electrons to flow. So allow electrons to flow through them. Okay, some do not allow. Okay, some do not allow electrons to flow through them, whereas some allow electrons to flow them. Those who allow electrons to flow through them, they are called good conductors. Those substances or material which do not allow electrons or electric current to flow through them, they are called insulators. And there are some material which allow electrons to flow through them partially. Okay, they are all metalloids, okay, or semiconductors. So mostly metals are good conductors of electricity. Okay, we have seen that electrical wires are made up of metal, right? And which metal is used to make electrical wire? Yes, that is copper. So copper is a metal which is used to make electrical wire. Then we have also seen aluminium is also being used to make electric wires. Yes, where have you seen aluminium? Yes, especially the street lights and for this transfer of electricity from the transformer to different houses, you have this aluminium wire is being used. So two types of metals are used to make wires, copper, aluminium, and we have also learned about metals and non-metal. In that chapter we have seen that these two metals are very good conductors of electricity, whereas non-metals or the other materials are called insulators. Okay, and metalloids are semiconductors, which you are going to learn in your higher classes. Okay, so what are conductors? Let us write down the substances which allow electricity to pass through them. They are termed as conductor. What's the meaning of to allow electricity? It allow flow of electrons. So it allow electrons to flow. Okay, it allows flow of electrons. And what are they? They are termed as conductors. Examples: metals, okay, the silver, gold, acidic solution, salt solution. We are going to see what are these things, okay. But right now let us focus on solid conductors. So solid conductor, metal, silver, gold, copper, aluminium, iron, okay. Among these, silver and copper are the best, you can say, very good conductor of electricity. Okay, now there are certain liquid which also conduct electricity. Now what type of liquid? We are going to see these things in today's class. Okay, acidic solution, salt solution, these allow electric current to pass through them, including water and human body. Therefore, when you touch electrical appliances, I said we get electric shock, isn't it? That means since human body is made up of 70% of water, we do conduct electricity. What are insulators? Insulators are those substances which do not allow electric current to pass through them, and we term such material as insulators. For example, plastic, rubber, okay, wood, glass, all these materials do not allow electric current, or rather they do not allow the electron to flow through them, okay, and therefore they are termed as insulator. And therefore, because of these, you can see these kind of material are being used as insulators for insulating the things. So the copper wires, okay, if you touch them while conducting electric, you may get electric shock. Therefore they are coated with plastic material, isn't it? Okay, so electrical gadgets like pliers and all, you must have seen they are coated with this plastic. Now why? So that when electrician is doing the electrical work, he or she should not get electric shock. Okay, this prevent the person from getting electric shock. Okay, these are termed as insulators. As I have already seen, it is conductors can be of two types: solid material, liquid material. So let's see conductivity of solid. Those solid which are good conductors of electricity. What's the meaning of good conductors? Allow electric current to pass through them. Okay, allow electric current to pass through. They are called good conductors. Which are the one? Copper, steel, iron, aluminium. All these are good conductors. I have already told you that metals are very good conductors of electricity. Okay, some of the poor conductors of electricity. So what's the meaning of poor conductor? Nothing but insulators. What's the meaning of poor conductor? Insulators, which do not allow electric current to pass through them. Okay, for example, wood, plastic, rubber. Okay, all these are insulators. Okay, we have already seen them. Now let us test one by one. Okay, we are going to test whether they are conductors or insulators. Okay, we have this object. Okay, blade, book, water, coin, tomato. Okay, so we have the first one, blade. See what happened when I put this blade at this place, when I place the object here. Bulb glow. That means conductor or insulator, conductor. Okay, so blade is conductor. Okay, next one, let us take the book. Book is insulator. See, the bulb do not glow, so book is insulator. So paper is insulator. Now let us check the glass. Okay, so the glass is also insulator. Okay, it do not allow. See, the bulb is not glowing, so insulator. Okay, let us do the next one. Here we have the coin. Okay, it's made up of metal, so conductor. Okay, so these was the small little activity that we have done. Now let's learn about, does liquid also conduct electricity? Yes, we have seen just now there are certain liquid which conduct electricity. Electricity is also conducted to our body. Okay, what are they called? So the liquid which conduct electricity, they are termed as good conductors of electricity. Okay, and liquid which do not conduct electricity, they are termed as poor conductors of electricity. It means some liquid allow electric current to pass through them and some do not allow. Okay. Now, what is conduction tester? Since now, how do we know which liquid conduct electricity, or whether it conduct electricity or not, whether it allow electric current to pass through them or no? For that we need conduction tester. Okay, what is a conduction tester? It's nothing but a device to determine whether a substance is good conductor or poor conductor of electricity. So how do I know that whether a substance is good conductor? So substance means here we are talking about whether a particular liquid is good conductor or whether that liquid is a poor conductor. I am going to use a conduction tester. So what is conduction tester? Is nothing but a device which is used to determine whether the given liquid is good conductor or poor conductor. You can make a conductor tester using a simple torch bulb. Okay, that's nothing but a simple electric circuit. What do you need? A battery or a cell. Okay, you need a bulb. Okay, and you need to make a small connection between them, and that it will act as a conductor tester. When you dip these ends or open ends of the wire in a conducting solution in a liquid, if the bulb glow, that means the electric current is flowing to the liquid. If bulb do not glow, that means that particular liquid do not conduct electricity. That's a simple circuit. Okay, so when we know that my circuit complete, obviously the bulb will glow. You can also make use of conduction tester using LED. Okay, now sometimes what happens, electric current flowing to the circuit may be very weak, and the filament of the bulb may not be glow. So the filament of the bulb is not getting heated up, okay, and therefore it may not glow. So instead of that, you can use a LED. What are LED? Light emitting diode in such circuit. Okay, why LED? Because some liquid conduct electricity, but maybe the flow of electron is very slow, and that is not enough for the bulb to glow, and that may not indicate. And we say that if the bulb do not glow, that means electricity is not flowing to the liquid. So to be test and to be very precise and to be very accurate, we can use these LEDs which used as conduction testers. So as I've already told you, what are LEDs? Light emitting diode. These glows even if the current is very weak. Even the current is weak, the current is flowing to the circuit, it can be detected using this LED. So this LED has two wires and these are called as leads of the LED. One is slightly longer and other one is shorter. So the longer and the shorter will be represented as positive and the negative terminals of these LEDs. Okay, so LEDs can be used to make conduction tester for conductivity of liquids. Okay, you can also make conduction tester using magnetic compass. So there are three ways of making conduction tester: simple circuit with bulb, second one with LED. Now you can replace the bulb with a magnet. So what will happen if a magnetic, when we know that magnetic compass, if it is kept near an electric current, if the current is flowing and if you keep a magnetic compass near that circuit, what will happen? Magnetic needle will show deflection. Okay, magnetic needle get deflected. Okay, that is because of one effect of the electric current that is being when current flows to the circuit, it behaves like a magnet. We have already seen that, and that's called magnetic effect of electric current. And since you are keeping another magnetic needle nearby this circuit, so what will happen? It will start showing the deflection. Okay, so you can use a magnetic compass to make the conduction tester. So when we use magnetic compass instead of torch bulb or LED, we say that such a tester is called as conduction tester using magnetic compass. So magnetic compass can be a very good replacement for a torch bulb because it will get deflected even if very weak current is flowing through the circuit. Okay, so for the conductivity of liquid, we can use magnetic compass or LEDs or torch bulb. Now let us do conduction test for conduction of liquid. Okay, testing conduction of electricity for liquids. Okay, so here I have taken the tap water. Okay, that's a magnetic compass and an electric circuit. Okay, what will happen when the two ends of the wires are deep in this tap water? Reduce the deflection? Yes, that means tap water is good conductor of electricity. What is tap water? Is good conductor of electricity. Let us see the next one. Now the next liquid I have taken sugar solution. What is it? Sugar solution. Okay, now check when the sugar solution is taken. See what happened. Ammeter is not showing any deflection. What is ammeter? Okay, ammeter, you are going to learn about ammeter in your higher classes. Ammeter is nothing but a device. Okay, ammeter is nothing but a device which is used to check or used to measure electric current. Okay, so in the ammeter it was not showing any deflection. That means this is poor conductor of electricity. Okay, so the sugar solution poor conductor. Let us test for lemon juice. See, you can see here the conduction tester is using magnetic compass. So here you can see the magnetic deflection. So lemon juice is acidic. Okay, so we know that this is conducting. So it is good conductor. Okay, good conductor of electricity. Now let us test for vinegar. Again, vinegar is nothing but acetic acid. Okay, a type of acid, a weak acid. Again, it is showing deflection. That means it is a good conductor. Okay, good conductor of electricity. So this test we have done to test whether the given liquid is a good conductor or poor conductor. We have seen vinegar, lemon juice and tap water. All these three are good conductor, whereas sugar is a poor conductor of electricity. So here comes the reason. Okay, the things that we can summarize from what I have already told you. The electrical conductivity of liquid. Certain liquids allow electric current to pass through them whereas certain do not allow. We have seen that lemon juice, out of the 4 liquid that we have taken, lemon juice, okay, vinegar, then tap water, they allow electric current to pass through them, whereas sugar solution do not allow electricity to pass through them. So the one which allow, they are called good conductor, one which do not allow, they are called poor conductor. So acids, salts, okay, they are very good conductors of electricity, and also bases, whereas sugar solution, they are oil, these liquids are poor conductor of liquid. Okay, so the liquid examples of good conductors of liquid: tap water, salt solution, acids, bases. Okay, sodium hydroxide is a base, hydrochloric acid is an acid. So all these solutions of acid, bases and salt are good conductor of electricity. Poor conductor will be distilled water which do not contain any salt, dissolved salt, sugar solution, kerosene, spirit, okay, oil, alcohol, all these are poor conductors of electricity. Okay, so here I have a question for you. I am ending the video with one question. I have NaCl, that is salt, and I have sugar. I have NaCl, salt solution, and a sugar solution. Which of the two will conduct electricity, and why? And another question for you is, the liquids which conduct electricity are called good conductors, and liquids which do not conduct electricity are called poor conductors. You are going to find out whether they have got any other name. If yes, do comment in the comment section. So here I am ending today's video. Thank you very much. And if you are new to my channel, kindly subscribe my channel and hit on the bell icon to get notification about the latest video. In the next class, we are going to continue our lesson. Thank you very much.